Hello, welcome to this lecture on Laplace transform, part 9. This is the Laplace transform and differential equation. We'll continue to solve differential equation. So this is the given differential equation, linear ordinary differential equation, second order. We will solve this differential equation, second order differential equation. All the given initial conditions all are given as 0. So let us solve this. If you take Laplace transform of the whole equation. So left hand side is this is a second order differential equation. So recall my lecture on it is part 1, I think. My lecture on Laplace transform part 1, where I had given you all the formula of Laplace transform, table of transform. So as per that, this second order differential equation. If you take Laplace transform of this, s square ys minus sy0 minus y dash 0, and this one Laplace transform of this is dy dt. Laplace transform of this is this, and y being y of t, Laplace transform of y is y of s. The right hand side is 1, so Laplace transform is 1 by s. So let me substitute all the given initial values. Initial values both y0 and y dash 0 are given as 0. So this will be 0, and this is 0, and this is also 0. So this is 0, 0, and 0. So remaining terms, if you simplify and take y of s common, you will get this. So y of s, if you simplify, you get this, and y of s equal to 1 by this. Now this is, there are two factors, s square, s and s square plus 3s plus 1. So I'll split into this by partial fraction. By the way, s square plus 3s plus 1 can also be factorized. It's a quadratic equation. It can be factorized into two real unequal roots. But the problem is the factors will not be real numbers. The roots will not be, the roots will be, they'll be real numbers, but the roots will not be integers. The roots or the factors of s square plus 3s plus 1 will not be integers. They are real unequal numbers, but they will be fractions. They will not be integers. So you can split into the two factors. You will get the factors. You get non-integer factors. So you can continue with that. You can do like that. But by taking partial fraction with this non-integer factors will be a little complicated, little more little lengthier. That's all. So instead of that, I'll continue to retain this s square plus 3s plus 1 as such, and we'll take up this keep this one term. So I'll take here as bs plus c. So then take LCM, you get this. So let me evaluate these coefficients a, b, c. If we compare independent term, that is s power 0 term, right hand side there is no s power 0. Left hand side s power 0 is just a. Independent term is only a. So right hand side, there is right hand side, there is an independent term which is 1. Left hand side it is a, and right hand side is 1. So if you take s power 0 term or independent term, you get a equal to 1. So next let us take s square terms. Yes. If we take s square terms, a s square plus you have b s square equal to, right hand side there is no s square term, so a plus b equal to 0. This gives me bs minus 1, because a is already 1, so b is minus 1. So next let me take what shall I take, s square, I take an s power 0, then I have to take s term. So let me take s term. So if you take s term, right hand side you have 3a, left hand side you have 3a plus what is other s term, cs. So 3a plus c equal to, right hand side there is no s, so 3a plus c equal to 0. A is already 1, so this should give me cs minus 3. So a is 1, b is minus 1, and c is minus 3. So let me substitute these values a, b, c here. So I'll substitute for a here, b and c. So if I substitute for a, b, c, a is 1, b and c, b is minus 1, c is minus 3, I taken minus out common. So bs plus c is s plus 3 divided by this. So I split this y of s into partial fraction, and I said I'm going to retain this s square plus 3s plus 1. So if I'm going to retain this s square plus 3s plus 1 without factors, then how do we take inverse? So let me see, I'm going to express this s square plus 3s plus 1 as a sum of two squares. Sum of two squares, or it can be even a difference of two squares. Sum or difference of two squares. So first two terms, s square plus 3s, can be written as some square. Try to write it as two squares. What will be the first two terms? Suppose if I write this as s plus 3 by 2 whole square. So the first two terms of s plus 3 by 2 whole square will be these two, right? S square plus 3s. Then what will be the next term? The constant. So first two terms of this s plus 3 by 2 whole square is this s square plus 3. So it plus or maybe even a minus some constant. Okay. So let me expand this. So s plus 3 by 2 whole square, if I expand, s square plus 3s plus 9 by 4, right? So if I expand this, s square plus 3s plus 9 by 4, but I need 1 here. Instead of 1 I got 9 by 4. So what should be this constant? Is it plus or minus? If you check this, should be 1 here, but I take a 9 by 4. So this should be 1 minus 9 by 4. Oh, so it's going to be minus 5 by 4. Right? So this s square plus 3s plus 1 splits into s square splits into s plus 3 by 2 whole square. That is the first term. Minus 5 by 4. 5 by 2 is nothing but another square root 5 by 2 whole square. So I split this term s square plus 3s plus 1 into difference of two squares, s plus 3 by 2 whole square minus root by 5 by 2 whole square. So this is what I'm going to substitute for this. I substituted this. So instead of this is 1 by s as such, and s square plus 3s plus 1 written as s plus 3 by 2 whole square minus this term. I written this as such, this. Okay. S square plus 3s plus 1 I written as difference of these two squares, s plus 3 by 2 whole square minus root by 5 by 2 whole square. So next step, next I'll split this term, the second term, the numerator of the second term. I'll keep the denominator as such. Numerator s plus 3 is split into like this. Why it is done like this? To make the numerator two terms similar to this, that is denominator first term the square is s plus 3 by 2 whole square. I'll make the numerator also s plus 3 by 2. So I'll make the numerator, modify the numerator s plus 3 like this. S plus 3 is made as s plus 3 by 2 plus 3 by 2. The idea is the first two terms is similar to same as the first square s by s plus 3 by 2. So when you do this, I did this, and then again now it becomes three terms. 1 by s is one term, this s plus 3 by 2 by the denominator is one term, and then the rest 3 by 2 by this is one term. Now do you now the Laplace transform, if you remember my lecture Laplace transform part 1, where I had given the table of Laplace transform, and if you are able to recall Laplace transform of sine and cos hyperbolic functions, Laplace transform of hyperbolic functions, as well as the rule translation of transform, then you will be able to quickly you will be able to invert this, take Laplace inverse of these two terms. Now what is the formula? So if you recall those Laplace transform table, the link for which I had given below, I had given the link below. So you will be able to recall that the Laplace transform of this e power minus at sin h sin hyperbolic at is this. So this is a Laplace transform of this, and this is the Laplace transform of this. So our given two functions, this function s plus 3 by 2 divided by this is like this, and the second function, this one, is like this sine hyperbolic, or this term. This second term is like this, and the first term is like this. And for the second term, okay, let me write the inverse of the first two terms, that will be easy first. So if you take Laplace inverse y of t equal to 1 by s is 1 minus, as I said, s plus 3 by 2, this term you can take it you can use this formula, s plus a by s plus a whole square minus k square. There is a minus here, so minus means hyperbolic function. Had it been plus, it would have been simply cos. This is minus, okay, so here it is minus the denominator, so it will be cos hyperbolic. So what will be this? E power minus at, e power minus a. What is minus a? What is a? A is 3 by 2, right? A is 3 by 2. So minus 3 by 2t. A is minus 3 by, a is 3 by 2. E power minus at cos h kt. K is, what is k? K is root 5 by 2. K is root 5 by 2. So that is inverse of first term, s plus 3 by 2 by the denominator. Now the third term, to use this formula, numerator should be k, right? Numerator should be k, but what do we have here? You don't have k here, you have 3 by 2. So this 3 by 2, I will split it into, 3 by 2 I will write it as 3 by root 5 into root 5 by 2. Okay, so 3 by 2 I split it into 3 by root 5 into root 5 by 2. So now the inverse will be what? So this 3 by root 5 is a constant. into e power minus at. Now this, if you take a 5 by 2, root 5 by 2 and the denominator, so it becomes perfectly this term, this formula. Okay, so this becomes this. So e power minus 3 by 2 t sin h of root 5 by 2 t. So this is the inverse of these three terms. 1 by s is 1, second term is this, third term is this. I hope you have understood this. If you take minus e power minus 3 by 2 t common, so cos h of this plus 3 by root 5 of sin h function. So this is the solution of the given differential equation. This solution of given differential equation is this. So I hope it is clear. So we have seen the last 3 or 4 lectures, different differential equations and the solution of the differential equations by means of Laplace transform. I hope you have understood. If you have any comments, you can leave the comments below. Please subscribe to this channel so that the next lectures, next videos come to you, or you are notified of my next video lectures. You will see more of differential equations in the next lectures. See you till then.